Okay, so welcome, first of all, to the Introduction to Engineering presentation. I'm here to talk about engineering because until I was 17, I didn't know what it was. So I think we all have an idea of what doctors, nurses, the police, and teachers do, but a lot of us probably don't know what engineers do. So today we're going to talk about engineering, where we'll look at the different exciting career prospects and jobs that engineers do, and we'll find out which one of you would make a good engineer. So, as I said before, your video and audio is off, but if you would like to ask any questions, you have been already commenting in the comment section. So, keep asking and answering questions in there. I'll have a bit of interaction during the video, so I'd really appreciate all of your ideas and thoughts to go in there. So, I'll begin with introducing myself. So, my name is Michelle Mac Lennan, and I'm a mechanical engineer with Fingleton White. So I guess engineering was always an obvious choice for me because when I was younger, I loved playing with Lego and other toys that allowed me to build things and take things apart. And I also liked maths and science in school. So engineering should have been an obvious option, but again, as I said before, I didn't know what it was until I got a lot older. Um, so then I got into college and I went to UCD where I studied mechanical engineering. I loved it. In my free time, I played with the Ultimate Frisbee team and I got to study abroad for a year in China. So it was really exciting. And then, as part of the course, I also got to work with a company for 8 months. So I did an internship with Fingleton White. And after I graduated last year, I went back and I'm now working full time with Fingleton White. So my day-to-day work varies a lot. Some days I'm working on drawings and designing things in the office, and other days I'm out on site visits, like in this photo here with my hard hat and my helmet on. So every day is different, which is really exciting. So now I want to hear from all of you to see what you think of engineering or what you have heard about engineering. So I guess first of all, who has heard of engineering before? Perfect. A lot of people have. That's great. And do any of you know any engineers? Like, are your parents or an aunt or an uncle, family friend? Some of you do, some of you don't. Great. Some sisters, some dads. That's good. This presentation is great whether you know someone or not in engineering. It'll just give a little overview of what everyone does. So next, I guess, is what do you think engineering is? What do you think an engineer does? What kind of jobs do you think they do? Some people have software engineers as parents. Yeah, Sean says they build things, fixing machines. Some people's parents did it in college. That's great. Yeah, they plan things. These are all very good ideas. Yeah, inventing. Make PlayStation games. That's a good one. That's one that probably would interest a lot of people. Exactly, yeah. Engineers can work with architects, is what someone is saying. That's very true, and we'll get to that later about the teamwork aspect. So that's great. There's been lots of good answers there. So I'll just give an overview now of some of the other jobs that maybe you do or like that you would or you wouldn't think of an engineer doing. So engineering, an engineer could work in so many different jobs. It's a very vast word. So engineering is very broad. There's lots of different types within it. So, for example, here in the first photo, we have an airplane that would normally take you on holidays if coronavirus hadn't taken over. But it's an engineer that will design the airplane and they'll look into finding the best type of materials to use because the heavier the airplane is, the more fuel it uses to get from A to B. So a material science engineer would study that. Then we see wind turbines. I'm sure a lot of you have probably seen these around the country. And it's engineers that design these. So an engineer will plan where they should be placed based on how much wind there is. And then the blade turns and it generates electricity. And the engineer makes sure that the electricity then can get from the wind turbine to your house, so you're able to charge your phone or your iPad. Then very different is biomedical engineering. So engineers can make equipment for doctors and surgeons to use. So they can make hip implants, which some of your grandparents might have, or say if you lost an arm or a leg in an accident, they can make prosthetic limbs, which are fake arms and legs that work equally as well. And then other engineers would work designing phones and electronics so that you can use TikTok, or even letting me present now over the screen to you. And then this is another very different one. So this is a chemical engineer. They might work with scientists in a lab to make sure that the medicine is safe, or packaging toothpaste and sun cream. And then finally, this is maybe what a mechanical engineer would do. So they design cars so they can go as fast as possible, like in Formula One. So as I said, engineering is very broad, and within that, there's different types of engineering. So we spoke about some of them on the last slide, and here's a few more. So as I said before, a mechanical or an electrical engineer might work designing wind turbines. A biomedical engineer might work with prosthetics. So this is what I was talking about, the fake arms and legs that work equally as well. As you can see here, they have a full range of movement. Then, as we see down here, an electronic engineer or robotics might be designing and building robots, which is something really exciting in the future. We can see here the robot is pouring out a drink. I see someone has some issues with some sound and picture. Is anyone else having issues? No, everyone else is able to see. Okay, hopefully they can. Yeah, you won't have it on for yourselves. It's just myself that's presenting. So as I was saying, electronic engineers might work with robots, and there's even some cafes already in countries like Japan where there's robots serving you. So it's really exciting time to get into engineering. There's lots of developments. And then another example here is civil engineering. So civil engineers would design buildings and structures like bridges. And I guess this GIF here is an example of what you don't want your bridge to end up like. So you go to college and you study engineering, so people don't have to drive over this bridge moving like this. I think that would be pretty scary. So if you become an engineer, I hope you learn better than this engineer did. So now that we know what type of work engineers do, I want you to see how engineering affects your life every day, no matter where you are or what you do. So I hope after this presentation, you'll be able to look around you all the time and notice which items you use were designed by engineers. So now it's over to you again. Can you spot anything an engineer might have designed in this photo? Guitar, submarine, Ferris wheel, the plane. Yeah, these are all right. Submarine, plane, boat, computer. You're seeing things I haven't even seen. The buildings, that's right. Earphones, exactly. You're picking out everything here. So what this really shows is that engineers touch every aspect of your life. They could, anything that moves, anything that's electronic, an engineer is involved in that. So I just picked out a few of the examples here, but as we said, you all picked out a lot more than that. So for example, we have the airplane here that we spoke about before, and the wind turbines. There's the boat that you said. There's the submarine. We've got the Ferris wheel and the roller coaster. Even these buildings in the background, a civil engineer or structural engineer would have designed these. And the sun cream is one that I think a lot of people don't necessarily always think of, but a chemical engineer would work with liquids like this. And yeah, again, this girl's even running and she has an iPod, which an electronic engineer would have made. So that's great. Everyone there gave great answers. So the next one now is a house. So this is what you would see every day going around now at home. So I hope now after this, you'll be able to look around your own house and see similar things. So can anyone see things here? Yeah, the car. I didn't even notice the car. The car, of course, yes. The car, the oven, the TV, computer, the building itself, very good. Thinking outside the box there, very good. Lights, the bath, exactly, the lamp. Great ideas. Yeah, the fridge, exactly. Very good. So again, I just put in some of the answers, but as you all saw in the comment section, there's hundreds of things in this house that are probably an engineer would have worked on. So again, when you leave this presentation today, just look around your house, look around your room, and just notice how an engineer affects it all. So now that we know what an engineer does, let's see if you would make a good engineer. I think you probably would because you've got a good eye for detail. So you picked out all those things in the photos really well. So the main traits of an engineer would be these 5 here. So the first one that I think is really important is teamwork. So when you're an engineer, you have to work as part of a team to come up with the best solution. So for example, we spoke earlier about the different types of engineering. So there's mechanical engineers, electrical engineers, biomedical engineers. So when you go into college, you specialize, you study one of those. So you might be the expert at mechanical engineering, but when you're designing something, different people need to have an input. So teamwork is really important. So no matter how well you know something, teamwork is important because you need to hear other people's opinions, other people's experiences will all impact the solution. So teamwork is really important. The next thing is you have to enjoy maths or science. I'm not saying you have to be Einstein. You don't have to be the top of your class in maths and science, but you just need to enjoy it because there is a lot of maths and science behind engineering. Next is you have to be creative and imaginative because engineers, as we'll come to next, are problem solvers. And when there's a problem, you need to think of a solution that no one has ever thought of before, probably. Because if they thought of it, they probably would have implemented it. So you have to be creative and think outside the box. You brainstorm and think of lots of different ideas. Then another sign that you might be a good engineer or might become a good engineer is if you enjoy problem solving. So if you like playing games like the Rubik's Cube or other games where you have to solve a problem, that would be very important because as we said before, engineers are solving problems. They notice a problem and they want to make it better. And then the last one here is a boy looking at his bike and he's curious. He's asking questions. He's like, how, when I move my feet, are the wheels now turning? How is it getting me from A to B? How do I balance? So all these questions are things that will go through your head when you start thinking like an engineer. You'll question how everything works. So things like questioning, oh, okay, so we've heating in the house, but how do the radiators get hot? What's in the radiator? Oh, so there's a boiler attached. The boiler heats up the water that's running through the radiators. So now the next slide, look here, is again looking at how engineers are curious. So engineers are interested in how and why things work. So here's again just some examples of your everyday life and thinking of some questions you might ask yourself. So say when you're brushing your teeth, what kind of questions would an engineer ask themselves? Yeah, very good. You might think, how is my electronic toothbrush working? How could I make this better? So someone's asking, why does that help? So I guess asking yourself questions will make you think of how to make something better. So if you're questioning, oh, how is the water coming out? And say the water came out very slowly. And you're like, oh, how's the water coming out? And then you're like, oh, that's how the water works. So we need to fix that tap so it can open wider and water can pour out faster. So asking yourself questions just starts making you think about how to solve problems. So other questions you might ask is, who made sure this toothpaste is safe? how did it get into the bottle? How did they put the cap on? So robotics would come into that. A lot of the items that you use in the house, it's not a human putting them together. They have robots on these assembly lines. So like when you go to the supermarket and you put all your groceries up on the conveyor belt and they go up to the cashier, that kind of idea. But instead of a cashier, there's robots and they're doing all the actions to fill the bottles, put on the caps. So other questions, making toast, like how does the toaster pop up? What makes that happen? How is it heated up? It's plugged into the wall, so it must be using electricity. Thinking about going to and from school. How does a car physically move from A to B when it takes us so much effort to walk? How does the car do it? And then you think, oh, you put petrol into the car or diesel or an electric car. And then from there, you start thinking about how you can make things better. Sitting in class, who designed the building so that it doesn't fall down? How can people walk upstairs and they don't fall through the roof? So that would be a civil engineer that would have designed that. Cooking dinner, there's certain things that you cook in the oven, others you cook in the stove, others in the grill. There's different, you use a saucepan on the top, but you wouldn't put a saucepan in the oven. So engineers would work on looking into the materials that would be used for that and what temperature they can withstand. And then the last one, even as simple as turning on and off the lights. How are you flicking a switch here and all of a sudden the light comes on here? So I've put a lot of questions out there now, and I'm not going to answer them all. I think it's really important for you to think about these questions. And if something really interests you, like say if you're not really interested in how the toaster works, but you're really interested in how, say, the car works goes from A to B. The internet has so many resources, and YouTube especially has lots of videos with information on it aimed at primary and secondary school students. So I've added some resources at the end of this presentation that you can look at afterwards to answer some of these questions. So again, we said that problem solving is important for engineers. So here are the 5 basic steps of problem solving. So obviously, first of all, we need to have a problem. And then once you have a problem, you need to brainstorm solutions. So you need to think of lots of different ideas, because the first thing that you think of probably isn't the best possible solution. So if we look at this picture here, it's actually a great representation of how teamwork is important. So each of these first 3 came up with good ideas. They were all similar, but a little bit different. But it was the 4th person that used the team working skill to listen to all the others and combine all their ideas and came up with the best solution. So that's normally step 3 as well. So you would pick the best and most suitable solution. So that will vary depending on the problem, what the best solution is. So the same solution to a problem for someone your age will be different to the solution for the problem for someone that's maybe your grandparents' age, because there's different restrictions. So then you need to make a plan. So a plan might involve making up calculations. So getting out your calculator. It might mean making drawings. So getting out your ruler and your pencil. Or there's there's softwares on the computer that you can do that now that you would learn if you study it in college. And then finally, after you've got the plan and you've maybe made a prototype. So sometimes a prototype is, if you wanted to build a house, you wouldn't just start building a full house without testing it out. So you might build a smaller version. So even first of all, you might build a little house out of Lego with the same dimensions, same relative dimensions. So it'd be smaller, but the same idea of what you want to build at the end. And this prototype will give you an idea of if it will work or not. So you might see when you put the little Lego person in, oh, the door is a bit small, the Lego person can't fit through. So we're going to have to change that dimension before we start building the house. Because obviously, if you start building the house and find out these issues, it's a lot harder to change. So now that you know the 5 basic steps of problem solving, do you think you can help me solve a problem? Great. So some people are enthusiastic, so I'll get your help for this. So a big problem is the pollution from cars. So, you know, when you're walking down the road and there's lots of cars, and you breathe it in, and it's not nice, and it's not good for breathing. If you have asthma, it makes it difficult. It's also bad for the environment. So let's say that's our problem. It's the emissions from cars that are from petrol and diesel cars. So that was number one. This step number two, that's brainstorm. So like, say you need to get to school and you can't use a petrol or a diesel car. How will we get from A to B? Great, yes, someone said electric cars, bike. That's perfect. Skates, you could rollerblade, scooter, exactly, any form, bikes, and all of those solutions, walking, cycling, skating, scooters, they're all great solutions because you're not using any energy. Well, you're using your own energy, but you're not using any fuel. Hybrid cars, very good. Ice skating, perhaps if you lived in a country, maybe you could ski if you lived in Norway or somewhere, but sadly, I mean, probably not sadly. In Ireland, we thankfully don't have the weather for that. Great, that's a lot of answers there. So that's most of mine. So here are some of the ones that I put down. So as you said, we could walk or skate or cycle. We could use an electric car or a hybrid. And as someone said there's also public transport. So you could use a bus or the Lewis in Dublin or the train. So say in our instance that you live really far away from school and cycling for 2 hours in the rain doesn't appeal to you. It's not really feasible. So let's say that's not an option. And then electric cars, you're all too young to drive yet, so that's not really a feasible option. Maybe if your parents were able to drive you to school, then maybe they could get an electric car or a hybrid. But let's say for this instance that's not an option either. So for this problem, let's say public transport is the best solution. So next we need to make a plan. So can anyone think of what kind of things you'd need to think about before you implemented a bus route? Yeah, you need to think about the cost. Yeah, you'd need to think about the time. So you need to put together a timetable, so people know when and where to get off. The distance, yeah, you need to look at the route. So where exactly will the bus go? Because if passengers don't know, they won't be able to get the bus. Yeah, emissions is also another good answer. So depending on how big or small the bus is, it'll use more fuel. Yeah, so that's some great answers. So we'll look here. So some of the things that I thought of, but there's a lot more things that you need to think about before implementing a bus route, is maybe making bus lanes on the road. So if you want to encourage people to take the bus, they want to make sure that it's as fast as driving. So you might implement bus lanes so that the bus can pass out all the cars if they're stuck in traffic. The next thing is maybe you need to think about where you need to place your bus stops. So if you didn't have bus stops, people wouldn't know where to wait and the bus driver wouldn't know where to stop. So you would need to think about where exactly, how far apart they should go. And you might need to put a shelter on them like this one here, because in Ireland we get really bad weather. So that's another consideration. And then another one I thought of was, as someone said, about the emissions. So you need to think of how many people will be taking the bus, because a big bus uses a lot more fuel to go the same distance because it's heavier than a small bus. So that all depends on how many people will be taking it and how often will they be getting on and off. So you'd probably do some surveys of the local community and see what the interest would be before you chose what size bus to get. You might also have to think about what kind of fuel these buses would run on. That's a great idea there. Someone said the internet. Oh no, the internet disconnected. I thought they were saying the internet on the bus. Some of the buses have the internet on them now. Is everyone able to hear me still okay? Is it back again? Great, perfect. This is part of the working from home now is normally I'd come into schools and give these types of presentations and we'd do experiments. But now with the working from home, this is my first time having to do it over the computer. So after we thought of all this and made the plan, we'd implement the bus route and everyone would be able to get to and from school. So I'll just briefly talk about some of these other exciting technologies that engineers have developed. But if you have any interest in these, feel free to look into them after this lecture. So as someone said earlier, video games. That's something a lot of people don't think about. Video games, engineers work on those. So I don't know if you've heard of coding before, but code is behind everything electronic that you do. So it's a set of instructions that the computer tells so that it can do certain actions. So video games use a lot of coding, and at the end I have some resources for you to learn how to code over the summer. So there's websites, there's millions of websites that have different ways to teach you how to code. So some of them are through game format. So you'll be playing a game like you would normally online or on PlayStation, but instead of using maybe the X or the arrow keys, you'll have to type in a line of code. So you'll be playing your game while you're learning. Oh, great. Yeah, someone's saying Coder Dojo. Yeah, I think I've heard of that one before as well. So it's definitely a great opportunity now over the summer to learn some of that. Something else is astronauts going into space. So so many engineers work at NASA. So they're the people that get the spacecraft into space. They're able to get the spacecraft to go to the moon and to orbit around it and then come back in again and everyone's safe. So a lot of work goes into that, and that's some really interesting work. A lot of astronauts have engineering backgrounds because when they get up to space, they need to know how to fix issues if they go wrong. So there's also a video in the resources later on how NASA deals with issues in space. Then next is 3D printing. So this is becoming really popular these days. And it's a really interesting technology because maybe 10 years ago, it wasn't on the market. It wasn't common at all. Whereas now I've gone into some secondary schools and they have their own 3D printer. So it's great because a lot of us probably have 2D printers. So you can print on paper. But 3D printers allow you to print 3D. So if you wanted to get a toy, the idea is you can do it now, but it'll become more popular in the future. You go onto these websites, you buy the design for a toy. It's only, a few euro, way cheaper than it would be in Smith's or Toy Master. You feed your printer. It's a different printer than the one that you're used to. It's a square, and you feed the printer plastic. You tell it the instructions that you just bought, and it prints out the toy, and you don't even need to leave the house. So there's lots of opportunities with 3D printing. And again, there's some videos at the end. This is an example of 3D printing food, which I thought was pretty cool. You can 3D print chocolate into different shapes and things like that. Even better for the world, we are now 3D printing houses, which is a lot cheaper than building them traditionally. And again, there's a video on that later. And also 3D printing clothes. So some people go to like the fashion school, and there's a video at the end of a girl that did her entire fashion line on the catwalk. All of her clothes were made out of 3D printed plastic. It's really cool. So then other things you might have heard of were the Alexa. Electronic engineers would have worked on that. Driverless cars are obviously in the works, and we all hear of pros and cons. So engineers are trying to work through those issues, and that's why problem solving is so important. So any problem you can think of with driverless cars or any of these other things, there's an engineer at a desk somewhere trying to figure it out. And the best thing actually about engineering is you're not at a desk the whole time. So you'll maybe make up your plan at your desk, but then you're going out, you're doing physical experiments, and it's mixing it up. And then robotics, as we spoke about before, are really exciting. maybe scary as well when you think of how smart these robots are becoming. So again, engineers are all working on that, and it's a really interesting time. So who knows what the future will look like? So these movies here are meant to look very futuristic and maybe impossible, but who knows? The engineers are working on so many different things. You don't know what the world will look like. Like all the technologies I spoke about earlier, they didn't exist 10 years ago when I was your age, but they'll likely be normal during your lifetime now. When you go into college, you'll be learning about completely different things than what I was learning about. Like even the difference when I went into engineering in my first year, 3D printing was quite new. And when I came out in fifth year, I'd already 3D printed something myself. I 3D printed myself a little wind turbine that worked. So it can be used to make prototypes as well, as we spoke about earlier. You can, use something as simple as Lego, or if you really, the more accurate you want your results to be, you might use something like 3D printing. So I guess what I want you to remember after this presentation is mainly that engineering covers a vast amount of different jobs. So if you have an interest in engineering, it doesn't mean that you're set on one exact job. So that was the thing that really attracted me, because I didn't know what I wanted to do. I just knew that I really liked maths and science, like problem solving, I like teamwork. So I went into engineering. I did my first year general, and then you get to choose afterwards which one you want to do. So it's good and broad if you're not sure exactly what you want to do. I also want you to remember the traits of a good engineer. So as we said, that you have an interest in maths and science, mainly that you're just not afraid of them. You don't need to be Einstein, as we said. You need to be creative and like teamwork, and then also like problem solving and be curious. And then I also just want you to remember that engineering touches every part of your life. So when you leave this presentation, just when you go about your daily routine, just have in the back of your mind, oh, an engineer designed this and an engineer designed this. And you just realize how many opportunities there are. So here are some of the resources. I won't spend too long on this now. But as I said, I'll be putting this video up on YouTube afterwards, and I'll leave links in the description box so that you can click on them easily. I'll send the information to your schools to send out. So Engineers Ireland have a lot of activities. So there's lots of little experiments here that you can do over the summer. They come with instructions, and most of the things that you need are all at home. Like this one here, like to figure out which way the wind blows, you just need glue, paper plates, a hard compass. They're all things that you can get easily. As we said before, coding, there's lots of coding resources. So here's just a few examples I came across here, but I know someone was saying Dojo earlier, and there's lots of different ones like that. So again, if you just go online and type in coding for primary school, lots of resources will come up, and it'll give you little descriptions, because some of them might appeal to you more than others. So it's good to find something that you enjoy so that you stick with it. You can also take this personality quiz to find which type of engineering would suit you best. So would you be better as a chemical engineer working on medicine, or would you be better as an electronic engineer? And then here's some of the videos. So again, they're all on YouTube. So this one is, NASA, and it's talking about how astronauts fix problems and how engineers send them to space. Then we talk about, this one here is about how bridges are so strong. This is the 3D printed house we spoke about, and then 3D printed fashion. So that's the end of the presentation. If you have any questions, I'm happy to take a few now. I hope it was informative and you learned something about engineering. I guess, does anyone have an interest in studying engineering now? I know it's very far down the line. What would be good subjects to do in secondary school is a question. That's a really good question. So each secondary school offers different modules or subjects. So things like technical graphics would be good, technology, engineering, then just the science subjects, like general science for junior cert, and then chemistry and physics in particular for leaving cert, or biology would be good if you want to be a biomedical engineer. Other things would be honors maths or maths when you get into school, if you put a big focus on that. That's a few of the ones. I personally didn't do technology or engineering or technical graphics. So don't worry if you don't do them in school either, because you can still get into engineering. Some schools don't offer, like my school didn't offer those subjects, so I didn't have an option. But I studied physics, chemistry, and applied maths, which I think is only available for leaving certificate. But yeah, there's lots of options, and I'm sure if you ask your teachers in school, they will have resources and they'll know which subjects you should take. Yeah, someone's asking if I am an engineer. So yes, I'm a mechanical engineer. So I studied for 5 years and I finished with a master's. So you can do a bachelor's and a master's combined, and that's what I did for 5 years. I'm a mechanical engineer with a company called Fingleton White. So yeah, I'm an engineer, and then yeah, someone saying that engineers do more than they thought. Like, I'm the same. Every day I come across new jobs that I didn't even realize engineers were involved with. What do you need to do when you're an engineer? So I guess as we saw there, there's so many different types of engineering. So if you're a chemical engineer, you might work in a lab, whereas I would never work in a lab for the type of work that I do. I work in the office. I would some days be at my desk doing up calculations on my calculator and Excel. I would get out my pencil and ruler and be doing up drawings. So it mixes it up. It's very different day to day. Do you have to be smart to be an engineer? So when I listed off the traits there, I didn't say anything about being smart, because everyone's smart in their own way. So you don't have to be, someone can be very creative and someone could be really good at maths and science. But if they don't have a little bit of each, that's going to affect them. So it's better to have a bit of all of them than to have one of them be amazing and the other stuff not so much. So I think you're all definitely smart enough. You're only in primary school now, so you've so much time ahead of you to focus on what you want to do. Someone did the test, the personality test there already, and they said they're supposed to be, that the test said that they'd make a good transport or civil engineer. So that's good. And then someone's asking now, does an architect do the same job? I think that's what the question is. So an architect is different. So if you want to be an architect, there's an architecture course in college that you do instead. Civil and structural engineers mainly would work with architects. So they do have to work together as part of that teamwork, and you have to listen to each other, because engineers would come from a different background to architects. So again, it's really important to listen and collaborate and, do that teamwork well. Where's the personality test? I'll put it back here for a second. But again, I'll be putting all of this on YouTube afterwards, so you can check it out then. So it's just this, if you just search Engineers Ireland personality quiz, it should come up. So thank you all for your attention. I'm really happy with the amount of interaction you all gave and the great answers. It's really good to see how you already know what engineering is. Even if you weren't sure at the beginning, you actually did know what it was. So thank you all for logging on. I hope you enjoyed it. And yeah, I'll send on more information to your teachers after this. So thank you.